So, part 2 of, what is this, 1.7? 1.7b. Okay. Again, I just want to go through a handful of examples just so you guys get some ideas on different techniques and so on and so forth. So I chose this particular example just to sort of emphasize the idea that, yes, we are in pre-calculus, but when it comes to problem solving, all math is fair game. And especially if it involves like geometric shapes, sometimes we might need to use a knowledge that we learned or should have learned in geometry. Take, for example, this question here. A man who is 6 feet tall wishes to find the height of a certain 4-story building. He measures its shadow and finds it to be 28 feet long, while his own shadow is 3.5 feet long. How tall is the building? And this is exactly how people measured really tall things back in the day. Ancient, Greece. How did they measure mountains? How did they measure tall buildings? They just stuck a stick in the ground and measure shadows. So this story involves lots of lengths, heights, shadows. I need to see that, so I'm going to draw a picture. I'm going to take my suggestion from yesterday and draw a picture. Now, I went to college for 4 years and went to graduate school for an extra 2 years, so I have 6 years of math drawing experience under my belt, but if your drawing isn't as good as mine, you can still solve it. So, this is my building. Glad I paid $40,000 to learn how to draw a building. And this building casts a shadow. So here's the shadow. It says the shadow is 28 feet long. Does it tell us the height? No, that's exactly what we're trying to solve for. So that's our variable. The height is our variable. The only other information they give me is, again, just scour through the problems for the information. They give you the man is 6 feet tall. So I need to draw a person. So here's my human being. There you go. And he also has a shadow of 3.5. And this is 6. Right. Now we are going to assume, and I think it's safe to assume, that we're assuming the ground is perfectly flat. He's not on a hill. He's not on a mountain. We're going to assume that the contractor did his job properly, so the building is perfectly vertical. He's not leaning or anything. We're going to assume that this human being has perfect posture and he's not slouching or anything. So I can safely assume that these angles are right angles. If we have a flat ground, vertical building, it's safe to assume it's a right angle. Now, when I solve problems, I don't like to have these like open angles. I like to have solid figures. So although it didn't tell me to, it's very natural to sort of connect the dots. Because when you connect the dots, we've now created geometric figures, and then we can use geometry knowledge. Well, what do you know? We created 2 triangles. And notice, again, based off our assumptions, if we assume that the ground is perfectly flat, I know that this line is parallel to that line. And again, assuming that the contractor who built the building was legitimate and you have perfect posture, I know that this line is parallel to this line. And if they both have right angles, what relationship do I know exists between these 2 triangles? They are what to each other? They are similar to each other. So recall from geometry, similar shapes have Jackie, you have a stay of execution. It's your time. So the idea from geometry is that similar shapes have proportional sides. What that means is when you have similar shapes, you can divide their sides and set them equal to each other. Now, it really doesn't matter which sides you divide as long as you're consistent. So for this problem, I'm just choosing random sides. Let's do, vertical divided by horizontal. Vertical divided by horizontal. And because they are similar, this is a true statement. X over 28 equals 6 over 3.5. Again, we can only do this because we know they were proportional. So to solve a proportional equation, all you got to do is cross multiply, go home, be done. That's it. Easy peasy. The question was, could we have used SOHCAHTOA? You could have if they gave you angles. Yeah. Since they didn't give us any angles, we could not have. Trigonometry. So 28 times 6 is 120. 168. Thank you. And divide both sides by 3.5. I have a calculator here. How? 48. Thank you. Okay. So the building is 48 feet tall. Okay. Which tells you that one story is 12 feet. Just random fact. Yeah. So that's the only reason why I picked this example. Again, nothing fancy, just to let you know that, hey, when you do these problems, you might have to use old geometry knowledge. I skimmed through your practice and I saw a lot of questions involving concentration. So I figured I should probably go over one example, especially if you've never done chemistry before. If you've taken chemistry, you should have done a whole bunch of concentration stuff, unless you were with a particular teacher. Regardless, I want you guys to sort of know how to do these types of problems. If you forgot what concentration is or never done any chemistry stuff, this is sort of like the Spark Notes or the concentration for dummies explanation. Concentration is just a fraction. It's a percentage. It's a comparison of how much substance you have to the total. So that's why this formula exists. The concentration of anything is the amount of stuff you have divided by the total stuff you have. And of course, you can manipulate this equation, get rid of the fraction, multiply both sides by total volume to get the amount of stuff you have is the concentration times the volume. And that sort of makes sense. If you imagine I have like salt water and 20% of it is salt, if I have 10 gallons, doesn't it make sense that 20% of that 10 gallons is salt? So that's all that the blue equation says. But the idea of concentration, what you have, divided by the total. So let's read the story here and see how this idea helps us. So suppose a manufacturer of soft drinks advertises that their orange soda as, quote, naturally flavored, although it really only contains about 5% orange juice. A new federal regulation stipulates that to be called, quote, natural, a drink must contain at least 10% fruit juice. How much pure orange juice must this manufacturer add to 900 gallons of soda to conform to new standards? Now, I know that sounds like a very complicated sounding problem. That sounds very high tech. Oh no, I need to be in the business to answer this question, but we can answer it with just straight up mathematics. Here's my suggestion to you. So tips and suggestion. Oh, get rid of the highlight. You don't have to follow this. I'm not saying every single concentration question can be answered this way, but these are my general hints and tips. You want to start with the original concentration, bless you, as a fraction. Then add or subtract whatever the problem tells you. In this example, we're adding orange juice. Then add or subtract whatever the problem tells you. And then what you want to do is then set equal to your new concentration. In this case, we start with 5% concentration. I'm going to start there. The problem says we're going to add orange juice, and then we want to end up at 10%. So once I finish rewriting my fraction, I'm going to set equal to 10%. Okay. So will these 3 steps help you solve every single concentration problem? Probably not, but it's a good place to start. These are just some general hints and tips here. So let's do it with this particular example. Right. You can't see the problem on my screen, but you have it in front of you. So you guys agreed, they told us we started with a 5% concentration. They told us that we have 900 gallons. So my question is, how much OJ did we start with? They told us we have 900 gallons at 5% concentration. So we should have 5% of 900 orange juice, right? That's just logic. I hope that makes sense to everyone. So what's that? That's 45 gallons, I think. 9 times 5 is 45? Yeah. So what is our original concentration? Remember that concentration is stuff we have divided by the total. So we have 45 gallons of orange juice divided by 900 gallons total. You guys agree? That is our original concentration. This is where we got 5%. 45 OJ divided by 900 total. Okay. According to the story, what am I doing to this bucket of soda? According to the story, what are we doing?
Filling it up.
I'm filling it up with pure orange juice. Okay. This is not a trick question. Usually when I ask kids questions, kids think, oh, he's trying to trick me, so I'm going to say the wrong thing. So let me be very explicit. The numerator is the amount of orange juice, and the denominator is total. Okay. The problem says we're going to add orange juice. Orange juice, right? Not apple juice, not grape juice, but orange juice. If I add orange juice, will I be changing the numerator, which is the amount of orange juice? Yes, good. You guys got that question. Let me ask this other question. If I'm adding orange juice to this vat, will I be changing the total amount of liquids we have? Yes. So do you agree, according to the story, hey, you're going to add orange juice. We will be changing both the numerator and the denominator. Okay. Do we know exactly how much orange juice we're adding? No, that's exactly what the question is asking, so that's going to be a variable. So since I don't know how much orange juice I'm adding, my equation will be 45 plus x, because I don't know how many gallons I'm adding, over 900 plus x. Does that logic make sense? When we add an unknown amount of orange juice, both the numerator and the denominator changes. Now, this right here is concentration because we're doing amount on top divided by the total. So this is the concentration of our soda. What is the final concentration that we want? According to the story, we want 10%. So we just have to set him equal to 10%. Voila, there's our equation. We can solve it now. So that's how you do concentration problems. At least that's how I do them. Start with the original. Then you're going to either add or subtract depending on what the question says. And then you're going to set it equal to the concentration that you want. Then the rest is just, this is a rational equation. We did rational equations in 1.5. I'm going to multiply both sides by the denominator to clear the fraction. So multiply both sides by 900 plus x. I guess I'll just show it for the notes. 900 plus x. 900 plus x. So that gives me 45 plus x equals 0.10 times 900 is 90 plus 0.10x. And then algebra 101. Get all the variables on one side, get all the numbers on the other. So I'm going to do two steps at once here. Let's subtract the 0.10x. And then let's subtract the 45. This gives me 0.9x equals 45. Divide both sides by 0.9. Gives you x equals, is it 5?
Yeah.
Sure it's not 50?
50?
50.
Okay.
Okay.
Sorry,
Yeah.
thank you.
And of course, it's a word problem, so just write a quick sentence. We need to add 50 gallons of orange juice. So you will have some concentration problems on today's practice. That's the way I would set it up. Start with the original concentration, read the story to see if we're adding or subtracting, and then set it equal to the new concentration and then solve. Okie dokie? Again, skimming through the practice, I saw a lot of these types of problems, and these are actually probably my favorite things to solve because the logic is just so cool. These are work problems. Now, these are your stereotypical, Sally washes the car in 4 hours, Mike washes in 2 hours. How long will it take them to wash together? Those types of problems. Now, here's the logic here. So this is sort of like the Spark Notes version of the idea that you should know. The idea is this. If you know the total amount of time it takes to do something, then to figure out how much of the job you've completed in 1 unit of time is just the reciprocal. Now, if all that doesn't make any sense, that's why I put a concrete example. So suppose it takes you 5 hours to clean your room. You either have a really big room or a messy room, who knows? If it takes 5 hours to clean your room, then if I take a unit of time, so just 1 hour, wouldn't it make sense that if it takes 5 hours to do the whole thing, in 1 hour you've done 1/5 of it? Yeah, and that's just the idea. If you know the total, 5 hours, then how much you complete in 1 unit is just the reciprocal, in this case 1/5. That makes sense? Okay. Well, if that makes sense, then if you have multiple things completing a job, all you have to do is add their progress. We'll see specifically with this example. So suppose you are filling up a swimming pool, right? And there are 2 hoses that you're going to use to fill up your swimming pool. We're going to use hoses because, who wants to use their own water? You got 2 neighbors, so just steal their hoses. So the first hose, you put it in your swimming pool, turn it on, and you record that it raises the swimming pool by 1 inch in 4 minutes by itself. You shut it off, you use the second hose, you turn it on, and you see that it raises the pool by 1 inch in 6 minutes on its own. And you're going, you know what, I'm smart. Instead of just turning one on and turning the other one off, let's run both of them on at the same time. That'll be faster, right? So your question is, how long would it take for both of them running to raise the swimming pool by 1 inch? Lots of information, sounds complicated, but all it is just an application of this logic here. So let's think through it. We agree we have 2 hoses filling up 1 swimming pool. So here's sort of like the idea. Would you agree that the amount, let's call it hose 1 and hose 2, amount hose 1 fills plus amount hose 2 fills equals amount both fills? And that's sort of like a no-dug thing, right? Isn't it true that if you take how much one thing fills plus the other thing fills, that obviously equals the total amount that was filled, right? Okay. We know it takes hose 1, what was it, 4 minutes? 4 minutes to fill an inch. Therefore, 3 dots in a pyramid is therefore. Therefore, let's apply this logic. If it takes hose 1 4 minutes to fill 1 inch, how many inches can this hose fill in 1 minute?
1/4.
1/4 of an inch. Does that logic make sense to everyone? Everyone okay with that? Therefore, it can fill 1/4 an inch in 1 minute. Let's do the same logic for hose 2. We know it takes hose 2 6 minutes to fill an inch. Therefore, it can fill how much in 1 minute? 1/6 of an inch in 1 minute. That logic makes perfect sense to everyone? I don't want to move on until everyone's in agreement here. I see some not certain faces. So let's just take a little sidebar here. So this is a sidebar. This has nothing to do with the hose problem. Let's go back to cleaning the room. Actually, I can't draw a room. So let's go to painting a wall. I can draw a wall. Here's a wall here. Let's say it takes you 5 hours to paint a wall. Right. So in 5 hours, this thing is completely filled, right? So here is a time-lapse video of you painting the wall. 1 hour, 2 hours, 3 hours, 4 hours, 5 hours. Let's rewind that and start over. 1 hour, pause. After 1 hour, if it takes me 5 hours to completely fill the wall, after 1 hour, shouldn't I be 1/5 of the way done? Because if it takes you 5 hours to paint the wall, it's as if you cut the wall in 5 pieces, and every single piece is 1 hour. If every single piece is 1 hour, what's the total amount of hours I have in this whole wall? 5 hours. How many hours is what part of the wall is shaded after 1 hour? 1/5 of it.
Okay.
Does that make sense?
Yes.
Okay. So it's the same thing, except we have inches and minutes. It takes 4 minutes to fill up, so in 1 minute it's 1/4. 6 minutes to fill up, in 1 minute it's 1/6. Well, I have 2 hoses. I turn them on, and I turn them on for 1 minute. This hose sprayed 1/4 of an inch. The second hose sprayed 1/6 of an inch. Logically, how much water is in the pool? What would I have to do to those numbers? Add them. That's it. All right, the water's going to the same place, so the water added. So the amount that hose 1 contributed is 1/4 of an inch, plus the amount that hose 2 contributed is 1/6 of an inch. That should equal the amount contributed by both hoses. We don't know what that answer is, so that's a variable, 1/x. There is our equation to solve. So it's a rational equation. Hopefully we are a little bit experts at solving rational equations. That was just 1.5. Clear the fraction. Everyone agree that the LCD is 12. So multiply everything by 12. This guy gets times 12. This guy gets times 12. This guy gets times... 12x, excuse me. 12x, 12x, 12x. So in the first fraction, you have a 3x. Plus the second fraction, you have a 2x. Last is 12. 5x equals 12. X equals 12/5. Right? It takes both hoses 12/5 minutes to fill an inch. Yeah. So work problems are very, very classic. If you know the total amount of time, then they complete 1/over the total in a unit of time. If you have multiple things working together at the same time, you add their units and set it equal to 1/x. Like I said yesterday, you're not going to magically absorb this. You just have to dive into it, try it, get a feel for it. But hopefully, with some exposure, we get a little bit better at word problems. So that's it. That is 1-7B.